In this video, we will discuss some of the graphical forms of quadratic equation, and later we will solve some of the previous JEE exam questions to understand how to apply this theory. Consider a function y equals to ax square plus bx plus c, where a is not equals to 0 and a comma b comma c belongs to real numbers. Now this function will be a quadratic equation when this value is equals to 0, and this value will be equals to 0 for at most two values of x, which are given by x1 comma x2 equals to minus b plus minus under root of b square minus 4ac divided by 2a. Now these values are called the roots of this quadratic equation, and the value inside this under root is denoted by a special term, discriminant. Now this function, when we draw it on xy axis, it takes a form of parabola, and depending on the value of a and d, it can take 6 type of different forms. So let's discuss them. So first case is when a is greater than 0 and d is greater than 0. So when d is greater than 0, we will have two distinct real roots for this quadratic equations, and the graph will look like and this graph will cut the x-axis as 2 points, which are the roots, and let's say we are given three values on the x-axis: alpha, beta and gamma. So there will be couple of cases for these values of alpha, beta and gamma with respect to the roots x1 and x2, and the first case is when the values of the roots x1 and x2 both are less than alpha. If both are less than alpha as shown in the graph, the value of this function will be greater than 0. So the alpha value will be greater than 0. For the second case, there is a value beta which lies between these two roots. And the value of the function at this point beta will be less than 0. Third case is when exactly one root lie between value alpha and beta. So for these values, the value of function f alpha multiplied by value of function at beta f beta will be less than 0, since one value is positive and other value is negative. So the product will be a negative value. And the fourth case is there exist values alpha and gamma for which both the roots lie between these values. At these two values, the value of function will be greater than 0. Also, there is a special point on this graph which occur at point minus b by 2a, and it always lies between x1 and x2 when the value of d is greater than 0. At this point minus b by 2a, when the value of a is greater than 0, the functions take the minimum value. Now since both the roots are lying between alpha and gamma, so minus b by 2a will also lie between alpha and gamma. Now the second case is when a is greater than 0 and d is less than 0. And the graph will look like now in this case this function fx will always greater than 0 for all value of x belongs to R. Now whenever you are given that the function is always positive for all values of x belongs to R, you should always think about a should be greater than 0 and d should be less than 0. This is very important. Now the third case is when a is greater than 0 and d equals to 0. Now when d equals to 0, both the root will take same value, which is given by b by 2a, and the graph will look like and this is the point minus b by 2a. Now this function will also be always greater than 0 for all values of x belongs to R except at the point minus b by 2a. Now there are three more cases when the value of a is less than 0 and the discriminant is greater than 0, when the value of a is less than 0 and d is less than 0, and when the value of a is less than 0 and d equals to 0. Now these three cases we will not be discussing in this video, but you can always multiply the equation fx equals to 0 by minus 1 to make the value of a greater than 0 in such cases and proceed in a similar fashion that we discussed previously. Now let's look at some of the questions that came in previous IIT paper and see how we can implement this theory. Now this question came in JEE 1990 exam and we are given that fx is a quadratic expression. So let's assume that fx equals to ax square plus bx plus c. Now it is also given that this is positive for all real values of x. So fx is greater than 0 for all values of x belongs to R. Now we know that in this case the value of a should be greater than 0 and d should be less than 0. So that implies is a greater than 0 and b square minus 4ac, which is the discriminant, should be less than 0. Now we are also given a function gx which is equals to fx plus the first derivative of fx plus the second derivative of fx, and putting the values we have x square plus bx plus c plus the first derivative 2ax plus b plus the second derivative 2a. Now rearranging the terms we have ax square plus, so clubbing these two terms, b plus 2a and these three are the constant term, c plus b plus 2a. Now the discriminant of this quadratic equation is equals to the square of the coefficient of x, which is b plus 2a to the power 2, minus 4 times the product of the coefficient of x square and the constant term. On further simplification, we have b square plus 4a square plus 4ab minus 4ac minus 4ab minus 8a square. So these terms cancels out and we subtract 4a square from minus 8a square. We have minus 4a square plus b square minus 4ac. Now we know that this term is less than 0 and this term is also less than 0. So the new discriminant of gx is also less than 0. And the coefficient of x square, which is a, is greater than 0. Hence gx will also be greater than 0 for all x belongs to R. Now this question came in JEE 2009 and we are given a quadratic function fx equals to 0. Now it is also given that this quadratic equation has real distinct roots. Let's say these are x1 and x2 and both of them are greater than equals to 4. Now we have to find the smallest value of k. Now since the roots are real and distinct, we have d greater than 0. And the discriminant of this quadratic equation is the coefficient of x square minus 4 times the coefficient of x square, that is 1, multiplied by the constant term 16 k square minus k plus 1 equals to 64k square minus 64k square plus 64k minus 64. So these terms cancel out and we have 64 multiplied by k minus 1. Now this value should be greater than 0. So that implies is k should be greater than 1. Now let's look graphically how the roots will be with respect to the value 4. So these are the roots x1 and x2 and this is the value 4. Now this point which occurs at minus b by 2a, since both the roots are greater than 4, this value will also be greater than 4. Now this is the coefficient of x in the quadratic equation, which is minus 8k divided by, this is the coefficient of x square, which is 1. So this should be greater than 4. So that implies is k is greater than 1. So there is one more condition. The value of this function at 4 is greater than equals to 0. So putting the value 4 in the function, greater than equals to 0, so we have 16 minus 32k plus 16k square minus 16k plus 16 greater than equals to 0. Or we have 16k square minus 48k plus 32 greater than equals to 0. Or we have k square minus 3k plus 2 greater than equals to 0. So this quadratic equation can be factorized into k minus 2 multiplied by k minus 1 and should be greater than equals to 0. Now for this product to be greater than equals to 0, this is 2 and this is 1. Now if the k lies somewhere here between 1 and 2, then this term is negative and this is positive, so the product will be negative. So k cannot lie here. If the k lies here, both the terms will be positive, hence the product will be positive. So the k can lie here. And if k lies here in this region, then both the terms are negative and the product is positive. So k can also come here. So for this product to be greater than equals to 0, k can either be less than equals to 1 or k can be greater than equals to 2. Now since we already know that k can be greater than 1, so this condition will not hold true and this condition will hold true, and the smallest value of k for which all our conditions will be met is equals to 2. Now this question came in JEE 2003 and we are given a quadratic function fx equals to x square minus a minus b multiplied by x plus 1 minus a minus b equals to 0, where a and b belongs to real number. So we have to find the value of a for which this equation has unequal real roots for all values of b. So for unequal real roots, we know that the discriminant of this quadratic equation will be greater than 0. So the discriminant of this quadratic equation equals to the square of the coefficient of x minus 4 times the coefficient of x square, that is 1, multiplied by the constant term 1 minus a minus b, and this value should be greater than 0. On further simplification, we have a square plus b square minus 2ab minus 4 plus 4a plus 4b greater than 0. Now this itself is a quadratic equation in terms of b. So b square and the coefficient of b's, clubbing them together, minus 2a plus 4 and the constant terms will be a square plus 4a minus 4, and this is greater than 0 for all values of b. In such cases, we know that the discriminant of this quadratic equation will be less than 0. So the discriminant of this quadratic equation is given by minus 4 times 1 dot the constant term, and this should be less than 0. So on simplification, we have 4a square plus 16 minus 16a minus 4a square minus 16a plus 16 less than 0. So these terms cancel out and we have 32 minus 32a less than 0, or 1 minus a less than 0. So this implies is that a should be greater than 1.